Welcome back to Jennifer our Chemistry Official, where we make chemistry friendly to all our learners. Today I want us to go through this question about the formation of a phosphine molecule and also the formation of a phosphonium ion. And to make it easier for you to understand the steps, I want us to have a major question on the formation of a phosphonium ion, because when you're forming a phosphonium ion, you do it in two major steps, where you first of all form a phosphine molecule, then you bond it with a hydrogen proton, and then end up with a phosphonium ion. So when you see me writing that we begin with the formation of a phosphonium ion, do not get confused, because when you'll be forming a phosphonium ion, in it we also will be forming a phosphine molecule. So let us have the steps together and make sure that you're writing something to make it easier for you to understand even better, because when you're doing something other than just following by hearing, you understand better. So formation of a phosphonium ion. We will first of all write the steps that are followed. We have two major steps, and the two major steps we have first of all the formation of a phosphine molecule. Which is the pH 3. Then from that point we have the addition of a hydrogen proton. The H positive to the phosphine molecule. When I say that, I mean this equation. So that is a summary of what you'll be doing. Make sure that you're writing. So let us begin with step 1, where we have the formation of a phosphine molecule, the pH 3. To begin with, in the question, we have been told to use the dots and the crosses. When we talk of the crosses, it is just a normal letter X. It is the one that will be representing the crosses. And the reason as to why we talk of using the dots and the crosses is because we are using different elements that will be bonding, and we would want to know which electron is coming from which element. So to avoid some confusion on which electrons are coming from phosphorus and which ones are coming from hydrogen. So the first point is where we determine which element will be taking the dot and which element will be taking the cross or the letter X to represent the electrons. So in the phosphine molecule, we have two elements. We have phosphorus and we also have hydrogen. So we can say phosphorus to take the dot and hydrogen to take the X. So electrons for phosphorus will be represented by a dot. Electrons from hydrogen will be taken, will be using or be represented by X. The next point is to ask ourselves, what is the atomic number for phosphorus? Phosphorus is atomic number 15. What is the electronic arrangement? 2.8.5. So from there we go to hydrogen. Hydrogen is atomic number 1 and with electronic arrangement of just 1. And then we have 3 hydrogens. So we needed to write the information about each one of them. And of course, the information is the same for all of them. The reason as to why we have to write for the 3 of them is to enhance our memory, that when you be drawing the energy levels, for phosphorus and also for hydrogen, we will use just 1 atom of phosphorus and 3 of them for hydrogen. So that's why we have repeated the same to show that hydrogens are 3 and phosphorus is 1. Another major point at this point is that when you check on the formula of the substance whose bonding is to be shown, you check on which one is alone or which one is just 1 and which ones are many. The one that is just 1 is the one that is usually written at the center, or rather drawn at the center. The energy levels for the one that is just 1 will be drawn at the center, and then the others that are many will be drawn surrounding the one at the center. So when you draw it, you'll see that phosphorus will be at the center, surrounded by 3 hydrogens. And then of course, remember which one is for phosphorus, it is a dot, and then for hydrogens, all of them, electrons, each one has a cross to represent the 1 electron that it has. Another major point that I need you to note is that the way I'll be showing you, you'll be required to keep on rubbing. So using your rubber. So I would then advise you to use a pencil in all the working. I have made the representation more clearer, where we have the column for the element, for the atomic number, for the electronic arrangement, and each of them, whether it is using a dot or a cross. So for phosphorus, it is the one we said we'll use a dot, and for each hydrogen it will be using a cross. So that representation will make it easier for you to understand and avoid confusion on what we have just done. Now begin the formation of a phosphine molecule, remembering that we'll be rubbing a lot, so it will be necessary if you use a pencil to make it easier for you to rub and keep your paper or your book tidy. So, and even in future, so as to keep your KCSE paper tidy to avoid confusion when marking is done. So then after you are through with the question, you can then use a pen to enhance the legibility of where you had indicated the electrons using a pencil. So let us begin together. We will first of all draw phosphorus, because as I said earlier on, from the formula of the phosphine molecule, which is the pH3, we have 1 phosphorus and we have 3 hydrogens. So we have 1 phosphorus combined with 3 hydrogens. So I had just said that the one that is just 1 is the one that will be written at the center, surrounded by the others that are many. So let us draw together. So we draw first of all phosphorus, starting with the nucleus, where we have phosphorus. So in between here, you can either write the formula for phosphorus, or if in case that information is given, you can write the number of protons and the number of neutrons in case the information is provided. But if no information is provided, then you only indicate the formula for phosphorus at the center. And when you're writing it, remember to make sure that now that it is just one letter that is being used, it must be a capital letter. So then, how many energy levels are we drawing? Remember, we just said that phosphorus is atomic number 15, so 2.8.5. So that this one will guide us to know the way we are putting electrons in the energy levels. So in the innermost energy level, and also remembering that we say that phosphorus will use a dot, we use 2 dots, these 2 electrons to begin with. Then the second energy level, we have 8. I like it better when you put them in twos to make it easier for you to count them. So those are 8. Other than putting them all over, you might indicate less or even more. So, but if you put them in twos, it makes it easier for you to count. So then we go to the third energy level, where we have 5. And now that you are expecting that hydrogens, each one of them will be sharing 1 electron with the phosphorus, and there are 3 of them, you can arrange the 5 electrons at the points where you think you'll be putting your hydrogens. So like for me, I'll be putting 1 hydrogen on this side, another one down here, and another one on the other side. So to those points, you can, for phosphorus, indicate 1 electron there, another electron there, another electron there, and because they should be 5, you then indicate 2 more at the top. So the arrangement is guided by where you think you'll be drawing the hydrogen atoms. So let us now draw the hydrogen atoms, and we should have them separately. So we come here and draw hydrogen. Hydrogen is atomic number 1 with electronic arrangement of just 1. Now that if you can't remember the first 20 elements, hydrogen is usually number 1. And when it is number 1, it means that atomic number is 1. So has only 1 electron, and so the electronic arrangement will just be 1. So meaning it just have 1 energy level. And also remembering that we said that hydrogen will be represented, electrons for hydrogen will be represented by a cross. So just 1. Then we come down here where we also draw hydrogen. Again with just 1 energy level and with a cross. We come to the other side, we draw another one. I hope you know the reason as to why we are drawing very many of them, and the many is just 3. It's because in the formula for phosphine molecule we have 3 hydrogens. And then of course they are bonding, so you make sure that you have shown that. Let me say this at this point. Sometimes it is very specific in the question that they require you to only use the valence electrons when you are doing your bonding. When they talk of you using the valence electrons, those are the electrons in the outermost energy level. So when the question is specific of the energy level that they want you to use, and mostly they specify and say they want the energy level with the valence electrons, then that will mean that then that time you only indicate the outermost energy level and avoid the other energy level. So in case you are told to use only the valence electrons, then this is how we would have drawn it. We would have drawn the nucleus for phosphorus, and then gone direct to the outermost energy level, which is this one, where we have 5, and then omit the other energy level, because the question then would be specific that they only want the valence electrons. So that time you not indicate the first energy level, and you will also not indicate the second energy level. You will go direct to the outermost energy level. So that is only when the question is specific that they want you to use the outermost energy level, or they say that you only indicate the valence electrons. Those are the electrons in the outermost energy level. For our case, it was not specific, and that is why I have taken my time to show you how all the energy levels will look like. So after the bonding has happened, then we go to the product side to show what has been formed. So in the product side, we will first of all draw the phosphorus the way it is. Let us draw it a bit better. We have phosphorus, we have the energy level, just the way it was, and indicating all the electrons just where they were. And then we go to the outermost energy level. So to the product side, I like it when it is drawn a bit bigger. Because it is at this point that you'll be showing how the outermost energy level for phosphorus is combining with each hydrogen to show how the bonding has happened. So you remember that there was this hydrogen at this point, because for phosphorus there was one electron there and 2 more up there, and another one on this side and another one down there. So we come with this hydrogen now, this one that is on the left, and we draw it here. We draw that hydrogen there, and we indicate the nucleus, and then we show the only one electron that it had. We first of all write it there. You see this point. This is what is very important at this stage. Then we go to the other side. We also show the hydrogen with the nucleus there, and it had this one electron. We indicate it there first. Then come down here, and we also show a hydrogen that was down there, and it had an electron, so we also indicate the electron at that point. So I hope you can see what I have just done. So the next step is to show how the sharing is happening. Remember, in our introduction in our previous lesson, I already said that in covalent bonding, we involve nonmetals. Remember, nonmetals react by gaining electrons. And in this case, because the two of them, the two elements, phosphorus and hydrogen, both of them requires to gain, meaning none of them is willing to lose. Both of them needs to gain, none of them is willing to lose. You see, if it was in ionic bonding, we involve a nonmetal and a metal. The metal is losing and the nonmetal is gaining. So you see there, the metal is willing to lose, and whatever it loses, it is the one that will be gained by the nonmetal. So there, they can assist each other, each one with its own problem. the nonmetal there in ionic bonding requires to gain, and it gains the electrons that has been lost by the metal. So, but in this case, in covalent bonding, there is a problem already that each one of them requires to gain, but none of them is willing to lose. So what they can only do is that they can only share whatever electrons that they have. It's like you meet someone, your friend, who is having some ugali on the plate during lunchtime. The person, your friend, is having ugali, and only ugali, nothing else, no stew. For you, you have the stew but no ugali, and both of you are very hungry. So none of you is willing to lose whatever is on his or her plate. So what do you do then? You say, if I give you a piece of ugali, you give me a piece of meat, if that is what was in the stew. If I give you another piece of ugali, you also give me a piece of meat. So by the end of the day, if you have given him or her 3 pieces of ugali, you are also expected to receive 3 pieces of meat. So there will be mutual sharing, like you give and he or she takes. You take, he receives. So that is what will be happening in our case here. So I always talk of this one to be the sharing basket. I call it a sharing basket because that is where they need to be putting, they need to put the electrons that they'll be sharing. So even you with your friend, when you be sharing your ugali, you need to have an extra plate to make it easier to know that you have shared 3 pieces of ugali and you have he or she has put 3 pieces of meat. So that is a sharing basket. So if phosphorus puts in an electron, hydrogen is supposed to reciprocate and also put his or her electron. So, but in this case it is not a human being, so hydrogen will also be putting its own electron. So let us begin. Phosphorus has this electron to share with hydrogen. So it is this electron that will be put here. And once we put it, we rub it. That's why I told you that we will keep on rubbing and rubbing. Now that phosphorus has put its own, hydrogen must also put something. So, and hydrogen has only 1 electron. So it is that one that has been put there, and then we rub. From there, we check whether this hydrogen has attained stability or has got now an energy level that is full. Hydrogen, in this case, is behaving like a halogen and is required to gain an electron. It had come with its own 1 electron, but it has gained another. That's why I'm saying it is at this point behaving like a halogen, because as a halogen it will be required to gain 1 electron. So after it has gained 1, it will now have 2, like the stable configuration for helium. So meaning that this energy level is now full. For hydrogen it has only 1 energy level, and for the rules that we follow when you are filling energy levels is that if an element or an atom has only 1 energy level, to attain stability, that 1 energy level must have a maximum number of 2 electrons, and that is what hydrogen has. So to look at the energy level for hydrogen, we check on the round, still considering this point, so all round. Let us first of all again confirm if phosphorus has also attained stability. For phosphorus to attain stability, it will be gaining 3 electrons, so as to have 8 in the outermost energy level. So I want us to check if phosphorus now has 8. So we begin by these two. So these two are counted for hydrogen, and they also counted for phosphorus, because it is an extension of the energy level for phosphorus and also an extension of the energy level for hydrogen. So we count for phosphorus 1, 2, 3, 4, 5, 6. So it is not yet full. So we can then go to this hydrogen. It gives its own, and phosphorus gives its own, and then we remember to rub, because if we forget to rub, there will be extra electrons. Then we go to this other one. Phosphorus gives, hydrogen gives, and then we rub them, and then we confirm if each of one of them is now stable. For hydrogen, we said it should have 2 maximum, so it already has these 2, because this is an extension of the energy level for hydrogen. Because when we were drawing this point, we extended the energy level for phosphorus and we extended the one for hydrogen. So where they are meeting is where we were calling the sharing basket. So we extended the energy level for phosphorus and the one for hydrogen. So we ended up with the sharing basket. So for this one, it is already full again with 2. Let's now go to phosphorus. We check whether it has now attained the stability with 8 electrons in the outermost energy level. So we count 1, 2, 3, 4, 5, 6, 7, 8. So our phosphorus is also stable with 8 electrons in the outermost energy level, and our phosphine molecule is already complete. So this is now the phosphine molecule. You can even write the name. It is the phosphine molecule. Before we wind up on the phosphine molecule, I want to show you something. That you see these 2 electrons for phosphine, they were not used for bonding. They were not used. This is what we call a lone pair of electrons. We call it a lone pair of electrons. And just like all of us know, when someone is just alone all the time, we talk of the person being lonely. The person being lonely. Somebody who always stays on his or her own and no company. So that person would become lonely. So from the one lonely, we get a lone pair of electrons. That is a pair of electrons that is unshared, that is not yet used for bonding. And actually, when we'll be forming a phosphonium ion, this is the lone pair of electrons that will be assisting us in the bonding. So that is how we have the formation of a phosphine molecule. In step 2, we have the addition of a hydrogen proton, the H positive, to a phosphine molecule to form a phosphonium ion. So in our steps, whatever I have just drawn is what we had in step 1, because in step 2, the first thing is for you to recopy or to rewrite everything that was in step 1, where we had the hydrogens surrounding the phosphorus, forming a phosphine molecule, because it is from the phosphine molecule that you are adding now a hydrogen proton. So from the beginning, from this point all the way here to this one, up to there, that is our step 1. Everything here from this end all the way to this other end, this is all what we did in step 1. So actually you can even arrange your paper like to have both steps happening, horizontally. So from that end to where I have drawn a dotted line downwards, that is step 1. So in step 2, we are only coming in to add the hydrogen proton. So you say plus a hydrogen proton. And then what we form is all this. So again, we recopy the product here. And then up here, we had the lone pair of electron. Up here, remember, is where we had the lone pair of electrons. That is where the hydrogen proton will be coming in to attach itself. That is where it will be attaching itself, because the hydrogen proton is coming in with no electrons. In one of the previous lessons, where we have the introduction to covalent bonding, I already explained that for a hydrogen proton to be formed, it is when hydrogen behaves like a group 1 metal. When it behaves like a group 1 metal, it will be losing the only one electron that it has. And now that it will be left with no electrons, so it will be having nothing to share with the phosphorus. It will only come with only one proton that it was left with in the nucleus, because it also do not have any neutrons. So after it has lost the only one electron that it had, and with no neutrons in the nucleus, it will only remain with one proton, and that is what it will come with. So this is another person, just like we had an illustration before. This is one person who have only come with a spoon, no food to share. This time round, no ugali, no stew, just someone who is hungry. And you yourself, you have both the ugali, you have the stew, but this person has nothing to offer apart from the spoon. So what will you do? You just share whatever you have. So this phosphorus that we have here has a lone pair of electrons, the 2 electrons at the top. Hydrogen is coming in with no electrons to share. So this hydrogen will come and attach itself up there. So having drawn the same diagram that we had for the phosphine molecule, because this diagram that I have just drawn here is what we had for the phosphine molecule. So the lone pair is still at the top. So this hydrogen proton will come in and attach itself there. So very nicely we indicate that this hydrogen is coming to attach itself there. So you see these 2 dots. Everywhere else we have a dot and a cross, a dot and a cross, a dot and a cross. But for this one, we have 2 dots. And at the beginning, we said that phosphorus is the one that is indicated with a dot. So meaning these 2 electrons are coming from phosphorus, because hydrogen has come in with no electrons to share, but has come with a positive. So then we put a square bracket, square bracket meaning it is a bracket with corners, and then this positive we put it on top there. So this is now the phosphonium ion. This is the phosphonium ion. That is the phosphonium ion that we have just drawn. So that is how it will look like. That is how it will look like. So, and make sure that you are drawing. Remember also, the brackets that we put must be square brackets, not the normal brackets. You see, the normal brackets looks like this, where they are rounded. So these are not the ones that you are supposed to use. These are round brackets. They should not be used in bonding we are instead using the square brackets where we have corners, and then we put the charge at the top. Finally, I want to show you something where we have the phosphine molecule combining with the hydrogen proton. If you were to show it using the single lines that I shown you, we'll have phosphorus, then a hydrogen there, another hydrogen here, another one at the top, another one down here. So when you look at this hydrogen, let me show you using this one. You see this hydrogen that is on the left, we have a dot from the phosphorus and a cross from the hydrogen, meaning that that one is a normal covalent bonding, so we put a line. When you go down here, we also have a dot from phosphorus and a cross from the hydrogen, so again it is a straight line to represent a normal covalent bond, where each one is producing an electron to share. The same with this one on the right, a dot and a cross, so again a normal covalent bond. But for this one, we have two dots, meaning that these have been provided by only one atom, that is phosphorus. So for that case, hydrogen has not contributed any. So there we won't put a line, instead we will put an arrow. An arrow representing a coordinate board. A coordinate board, and we usually have a line in between the O's. A coordinate or a dative board. So this one with an arrow. But for the rest that have single line, they are the normal covalent bonds, where each one of them has an electron to share. So that is all what I had for today. For your assignment, I wish that you go try the formation of an ammonium ion, and even for ammonium ion, it will also be following two steps. Ammonium ion, it will have the step one where we have the formation of a ammonia molecule, and then the second step where we have the ammonia molecule combining with a hydrogen proton. You can also try the one for water molecule and the formation of a hydroxonium ion. So again, following two steps, where the first step is the formation of a water molecule, and the second step is where the water molecule combines with the hydrogen proton to form a hydroxonium ion. So I'm really wishing you the very best. So make sure that you are practicing, you are equal to the task. I trust your potential. However little potential you have today, if you keep on working hard, that hard work will pay. And I always tell you that hard work, once it pays, you will smile all the way to your university of choice or to your college of choice, and all the way to your grade of choice. So I'm really wishing you the very best. Have a good time. God bless you. To the new subscribers, I really appreciate. Welcome home. To the returning subscribers, thank you very much for your support. Keep on telling a friend to tell a friend. Keep on sharing this information. Keep on commenting. Keep on liking. And I'll gladly receive your comment on which other area in our syllabus that you find a challenge in. And I will gladly prepare you a lesson and simplify it as much as I can. Thank you very much.